Hi, welcome back to another Math 112 lecture. We're going to round out this term, with a section on conic sections, a discussion of conic sections. Now, I do want to tell you that the textbook section for this unit is not in our usual textbook. So I want to show you where to find the text, because our normal textbook link won't get it for you. So click on the module 7, Hooked on Conics. Sorry about the 7. This happens to be chapter 7 in its textbook. But once you click on that, it will open up this module page. And if you click on the textbook Hooked on Conics, it will open up your textbook in a frame. And if you don't want to read it in the frame, you can click right here on the title and it will open it up for you. This chapter's not terribly long. I'm not sure how many pages, but if you want to print a copy, it won't be that hard for you to get it printed. So let's go ahead now and get back to our presentation. So conic sections are a specific class of curves that represent the different shapes that we get if we take a plane and we slice through a double-napped cone. Now, a double-napped cone is just a fancy math speak way of saying an hourglass. And you can see that if we take a plane and slice it through our cone at an angle, we get a parabola. If our plane is perfectly horizontal, we get a circle. If our plane is at an angle but slices through both sides of our cone, we get an ellipse. And if our plane is vertical, we get something called a hyperbola. Now, it turns out that parabolas have got some pretty cool properties, and actually so do hyperbolas, which shouldn't surprise you too much because a hyperbola kind of looks like two parabolas. Yeah. Be sure and read the section in your textbook on all of these. I'm going to go through the basics in this presentation of how we define the shapes and how we handle their equations in standard form. But in the interest of not boring you to death, I'm not going to talk about some of the cool applications of a parabola, such as whispering chambers or parabolic mics or satellite dishes. Those are all based on a parabola and it has to do with the focus. So I'm going to leave that for your reading from the textbook. So be sure and take a look at the textbook sections on these topics. So let's start with circles. Circles are the most basic of the conic sections. We call all of these shapes conic sections because they come from the slicing of a cone. We talked about a circle early in this term when we talked about the unit circle. Remember that the center is at the point HK. A circle is defined as the set of all points that are a given distance from a single fixed point. And the standard form for a circle is that the radius squared equals x minus h, where h is the x-coordinate of the center, squared, plus y minus k squared, and k is the y-coordinate of the center of the circle. This is a fairly familiar equation by this point, I'm sure. So, as an example, let us write the equation of the circle that is centered at the point -2, 3, and has radius equal to 5. So remember, the standard form of the circle is given by the equation x minus h squared plus y minus k squared equals the radius squared, or x minus, h is the x coordinate of the center of the circle, so negative 2 squared plus y minus 3 squared equals 5 squared. Or we usually leave this just as x plus 2 squared plus y minus 3 squared equals 25. Not too bad. So suppose we want to graph the curve represented by the equation x plus 2 squared plus y minus 1 squared equals 4. Now I let Desmos do the graphing for me, but I'm going to show you how you can find all of this. So recall your standard form, x minus h squared plus y minus k squared equals r squared. So if we want to find the center is located at the point hk. H is the number that is subtracted from x. This is x plus 2, that's x minus a negative 2, so my center is at negative 2. K is the number that is subtracted from y, which is 1. So center is negative 2, 1. The radius is the square root of 4. So r equals 2. And there we have it. Okay. Our equation is not given to us in standard form. Occasionally, we're going to find that our equation appears in this expanded form. We've got x squared plus 4x plus y squared minus 2y equals, or plus 1 equals 0. Now, we're going to go through all of the different conic sections, but one thing I want you to notice is that for a circle, both x and y are squared, and both x squared and y squared have the same coefficient. In this case, the coefficient is 1, but that's not always the case. But if those two coefficients are the same, you will know you're looking at a circle. But we cannot easily determine the center or the radius because this is not in standard form. So we're going to put it in standard form. And we put this thing in standard form by completing the square. Now we're going to do a lot of completing the square in these last 2 weeks of the term. So if you don't remember how to complete the square, and if you haven't recalled how to do that by the end of this lecture, there's a nice little tutorial here at this link. And I will also put this link on, actually I have already put this link on the Canvas website, I believe. Let's check that out. Oops, sorry. Still getting used to this computer. Back. I did right here where it says circle tutorial on our Canvas shell. Perhaps. I have to click on the title up here. Yes. This is a tutorial on completing the square. So I'm going to walk us through doing this, but if you really don't remember how to do it, that tutorial will help you. So here's what we do. In order to complete the square, what we're trying to do is we're going to gather all of our x's together. So we've gathered x squared plus 4x into a set of parentheses. If there is a coefficient in front of the x squared, we will factor that out. Now, what I'm going to do is I'm going to add something to this set of parentheses. And what I'm going to add is half of this number squared, and that's where this 4 came from. When I do that, this trinomial will always be a perfect square trinomial, and it will always factor. So I have factored this x squared plus 4x plus 4 into x plus 2 squared. Now notice I added 4 to my equation. Can't do that. It'll unbalance my scales. So I added 4 on this side as well. I can add something as long as I add it to both sides of the equation. So we'll gather our y's together and do the same thing with our y's. We gathered the y's. Oh, I messed this up. Let's fix this. I'm going to add, not 4, I'm going to add 2 over 1, or 2 over 2, so half of 2 squared is 1. So I'm going to add 1, which means this now should be 1. So I've got x plus 2 squared times y minus 1 squared equals negative 1 plus 4 plus 1 is 4. And this, we can see, has got a center at negative 2, 1, and radius 2. All right, so let's do this again. Let's complete the square in order to put this equation in standard form. And so what I'm going to do is I gather my x's together. So 3x squared minus 6x. Gather my y's together on the same side of the equation. And I'm going to move my constant term to the opposite side of the equation. That's step number 1. Now, step number 2 is actually I'm going to pull a 3 out everywhere. So because this is a circle, it's easy because x and y have got the same coefficient. So I'm going to pull a 3, divide through by 3 everywhere. When I do this, I'm going to go ahead, I'm going to leave a couple of blanks because I know I'm going to add something. So I'm going to add 2 things on the left, so I'm going to leave myself space to add 2 things on the right. Now what I'm going to add is, as I complete the square, I always add the same thing. I always take the number that's in the middle. So in this case, negative 2. I divide that by 2, and then I square it. So I added 1. I added 1 on the left. I'm going to add 1 on the right. For the y's, I'm going to take 1/2 of 4/3 and square that, which will give me 2/3 squared, so that's going to be 4/9. All right, now we'll factor. This guy will factor as x minus 1 squared. The y's will factor as y plus 2/3 squared. And that's going to equal r squared, which is 25/9. So my circle has got a center at 1, 2/3, and a radius of the square root of 25/9, or 5/3. Oops. Okay. So one more example. We're going to, in this case, we're given a circle and asked to write the standard form of the equation. Now this would be easy if we were given a radius, or a radius and a center point, but we're not. We're told that the circle has got diameters on -1, 3, and 2, 4. In other words, the circle goes through those 2 points, and those 2 points are at opposite sides of the circle. So how do we do this? Well, the first thing we know is that the center is at the midpoint of that diameter. So it's going to have coordinates at the average of the x's, so -1 plus 2 over 2, and the average of the y's, so 3. My pen is not. Let's try this again. 3 plus 4 over 2. I'll get my blue back. Or at 1/2, 7/2. That's my center. Now how do I find my radius? Well, the radius is going to be half of the distance between those 2 points. So that's going to be 1/2 of the square root of the difference in the x's squared plus the difference in the y's squared. So that's 1/2 of the square root of -3 squared is 9, plus 3 minus 4 is -1 squared is 1. So that's going to be the square root of 10 over 2, or r squared is going to be 10/4. So that means my circle is described by the equation x minus 1/2 squared plus y minus 7/2 squared equals 10/4. Okay? All right. And that is the sum total of what I want to talk about with regards to circles. This will let you do the first set of conic section homework. And I'll see you soon, and we'll talk about parabolas. Have a great day. Do good math.